AQA level chemistry practicals. Okay, so the first one, separation. What does separation do? Separation removes water-soluble impurities from a product. If a product is insoluble in water, then we use separation to remove impurities that dissolve in water. First thing we want to do, pour the mixture into a separating funnel and add water. Shake the funnel and allow it to settle. What will happen is that the organic layer and the aqueous layer are immiscible. They don't mix, so they'll separate out into two distinct layers. Pour the mixture in separating funnel, add water, shake funnel, allow it to settle. Organic layer and aqueous layer are immiscible, they don't mix, so separate out into two distinct layers. Open the tap and run each layer off into a separate container. However, if product and impurities are both soluble in water, we use something called solvent extraction. First thing we do, we take an organic solvent in which the product is more soluble than it is in water. Add to impure product solution and shake. The product will dissolve into organic solvent, leaving the impurities dissolve in water. The solvent containing the product is then run off using a separating funnel. Remove water from a purified product by drying it. So we need to add an anhydrous salt, magnesium sulfate, MgSO4, calcium chloride, CaCl2, the two most common ones. They're used as a drying agent, and what they do is they binds to any water present, becoming hydrated. First thing we want to do is add the salt to organic layer, and what will happen is that it will clump together. Once we add the salt, anhydrous salt, to the organic layer, it will clump together. So we want to keep adding the drying agent until it disperses evenly. Once it disperses evenly, that's when you swirl the flask. Filter the mixture to remove, disperses evenly when you swirl the flask. Filter the mixture to remove solid drying agent by popping a piece of filter paper in the funnel that feeds into a flask, pouring the mixture into the filter paper, and the filter paper can be fluted, the condenser folded to increase the surface area. Volatile liquids can be purified by distillation. You want to connect a condenser to a round bottom flask containing the impure product in solution. This is volatile liquids, remember. Place a thermometer in the neck of the flask so the bulb sits next to the entrance of the condenser. The temperature of the thermometer will show the boiling point of substances evaporating at any given time. Heat the impure product. When the product you want to collect boils, i.e. when the thermometer is showing its boiling point, place a flask at the open end of the condenser and collect the pure product. And this is the equipment, like your diagram. So you got this, heat, your impure product, your condenser, thermometer, water out, water in, and then your pure product. Organic solids. Organic solids can be purified by recrystallization. What we want to do for this, we want to add very hot solvent to impure solid until it just dissolves. We don't want to add too much solvent because this will give us a saturated solution of impure product, and that's not what we want. We don't want a saturated solution of impure product. Filter the hot solution through a heated funnel to remove any insoluble impurities. Leave the solution to cool down slowly. Crystals of product form as it cools. Remove the liquid containing soluble impurities from the crystals by filtering the mixture under reduced pressure. Okay, what we want to do is pour mixture into filter paper lined Buchner funnel. A flat bottom funnel with holes in the base of it sitting in the side arm flask attached to a vacuum line. Wash the crystals with ice cold solvent to remove any soluble. So we wash the crystals with ice cold solvent to remove any soluble impurities from the surface. Leave the purified crystals to dry. How to use melting point apparatus to accurately determine the melting point of an organic solid. Pack a small sample of solid into a glass capillary tube and place it in the heating element. Increase the temperature until sample turns from solid to liquid. Measure the melting range, a range of temperatures from where the solid begins to melt to where it has melted completely. Look up the melting point of the substance in data books and compare it to your measurements, your melting range and measurements. Impurities in sample lower the melting point and broaden the melting range, and they increase the boiling point. So the boiling point will be raised, lower melting point, and broaden melting range. And here's equipment. So you get thermometer, that's your sample. Here's a temperature controlled, increased temperature for sample turns from solid to liquid, and that is your heating element.